So I'm going to discuss habitable zones for a little bit here. Hi, Celeste. NASA Planet Hunter finds Earth-sized habitable zone world. For those that don't know, obviously if you're watching me yammer about, the TESS Space Telescope has been finding worlds outside of our solar system. And check out this graph here, or little illustration here. The green is the habitable zone. The central object is clearly the red dwarf in the center, and you have TOI 700 Delta, TOI 700 Charlie, and TOI 700 Bravo. Bravo is the one inside the green zone. That's the habitable zone. That's the area of the star where water can pool on its surface, potentially because of the heat of the hotter host. So basically, in the black area nearest to the star, right here, is where it's too hot, the water would boil away. It would be a hellish world, not very friendly to life, and most importantly, water wouldn't pool, it would just start boiling away over time. Granted, the conditions are similar to Earth. As well as the area outside of the zone, it's too cold. The ocean would freeze over and it would turn to ice. It would just be a snowball Earth. There's only, or I wouldn't say there's only one problem, I'll say there's a couple of problems with this. A habitable zone in the general theory isn't just the area outside of a hotter host. A habitable zone is a zone where water can be water. It has the pressure and it has the right temperature. It has a Goldilocks configuration, just like the three bears. I can't remember what that fairy tale is called, but Goldilocks goes in and she sits on a bed. One bed's too hard, one bed's too soft, and she finds they're just the right bed. It's just the right comfort. And she eats soup. Well, some of the soup is too hot, some of the soup is too cold, and she finds the soup it's just right. She picks that, on and on, so forth, so forth and so on. Same thing with this. With a object that's orbiting a hotter host, it isn't just about the hotter host, where the zone has to be just right. It's actually inside of the star itself where the zone has to be just right as well. For instance, if you take Mercury, for instance, it doesn't have an atmosphere, and you put it in orbit around another host star inside the green zone, if you put Mercury in here, there isn't going to be life forming there. It's not going to be hospitable life because Mercury doesn't have an atmosphere. The pressure would be way, way, way too low. Any water potentially that would be there would evaporate away, it would boil away because it's basically vacuum, it has no atmosphere. You need an atmosphere to maintain a liquid water surface. So to say a Earth-sized object is in the habitable zone, might have water on it, they're neglecting the majority of the required characteristics. And I've written a paper about this, and I'll post it to the bottom. But essentially, as a star evolves, you have your hot blue star in the center, and you have your habitable zone where another object can orbit around it and maintain a liquid water surface. And as the star evolves, that zone not only collapses, it gets smaller in diameter, but it thins as well. So you'll have a really wide area and a very large area, but then as the star evolves, two aspects of it get smaller. So it gets thinner and it decreases in diameter the more evolved the star gets. But astronomers, they don't have objects or the stars evolving in that way. This is what's called, I can't think of the word for it, but it basically means, like, sure, it looks to be a certain way, and for someone that has common sense, that's the way the stars should evolve. But the NASA astrophysicists, they don't realize this. They don't understand it. They don't have these objects, this bright blue object evolving into the yellow, into the red, and then continuing on and on down the line. Those are individual paths based off of various ad hoc stellar evolution models that were invented back in the 1950s and 1960s. They're over half a century old, and they're completely false. But unfortunately, they're still taught in school. For those that need a refresher on this, as the star moves past M dwarf or red dwarf stage, the M dwarf becomes a brown dwarf, and its heat, it can't provide the heat required for it to have an external habitable zone, meaning there's no green zone far away from the central object. That green zone starts collapsing and getting closer and closer and closer to the surface of that brown dwarf. Eventually, the area where it can maintain liquid water is the actual surface itself, and then the high atmosphere, and then it starts moving inwards as the higher atmosphere starts to get colder and colder and colder, and it stops radiating strongly as it did in the M dwarf or red dwarf stages. And I did a little drawing here. So basically, you have the bright blue habitable zone, blue giant habitable zone, and then it goes to a white star, and then the yellow, and the orange, and the red, and the brown dwarf, and eventually, late brown dwarf stages, the habitable zone moves into the star itself, right into the interior. And Baz had done another diagram for me. This is a much prettier diagram, I should say. Habitable zone is way out here as the star is really hot and energetic. And as it evolves, this is a line of evolution, that zone starts collapsing and moving towards the star itself. So this is the time variable. And then this is where the habitable zone becomes internalized to the star. And becoming an internalized habitable zone is very important because it means you don't need a host star to keep it hot. I guess a good analogy for it would be to I don't know. As weird as it sounds, this is going to be a stupid analogy. But imagine you have two campfires and they're separated by about a football field of distance. Saying a star needs an external, or it needs the heat of a host star to keep it hot is like saying a campfire needs another campfire a football field away for it to remain hot. That doesn't make any sense. It can maintain its own heat by itself. It doesn't need the external heat of another campfire outside of it to maintain its heat. But that's what astronomers are saying. They're saying that in order for one campfire to be hot, it needs another campfire somewhere really distant from it to heat it up, to keep it hot. But that doesn't make any sense, does it? But that's exactly their mentality. And basically, what we have here is a kind of weird understanding of our very solar system itself. There was this one book I was reading called The Overview Effect. It was written back in, I think, 1987. And the author had interviewed, or at least found a lot of interviews of astronauts when they were, they left the surface of the Earth. And then they could see the Earth as a giant ball, in some cases like the Apollo astronauts, or if they were just in orbit for maybe a week or two, or even a whole year. They kind of pulled their mentality and their consciousness outside of their daily experience, and they could see the Earth in its entirety. And the overview effect kind of leads us to the realization that, yes, that's what's going to happen in the future. Eventually, human beings, we're going to leave the Earth. And when we do visit other celestial bodies, it's gonna change the way we look at the universe. To think we can see Neptune through a telescope just fine, or with binoculars, or we can see it on a computer screen and say, oh well, yeah, that's Neptune. But to think how incredible it would be to be in a spaceship, having left the Earth, traveling at incredible velocities, maybe even close to light, to visit Neptune, and to actually see that giant blue ball as it really is, and to actually orbit around it and just to observe it with your own eyes, like in your face. That would be insane. I can't even imagine how that would change a person's, understanding of their place in the larger galaxy, I should say. And the reason why I'm talking about this is because there's kind of this idea, and I see it in the habitable zone ideas, where scientists, they think that water really only exists similar to the Earth. Like, there has to be a rocky object and then there's water on the surface, which is completely untrue. Because as stars evolve, they take two of the three most abundant elements inside the star, hydrogen and oxygen, and they combine them together to make water. All stars, as they evolve, make water. Some a lot more water than others. Some, they evolve really, really fast, and the water just sort of evaporates because it had been taken in by a hotter host, which ripped it apart before it could form a very large object like the Earth. But in short, water is something that's very common in the galaxy. Water is everywhere. It's something that a star forms in large amounts as it evolves. But the habitable zone people, when they talk about water pooling on the surface, they don't look at water as being inside of Neptune, or inside of Jupiter, or inside of Saturn. They sort of go, well, Neptune and Uranus, they're ice giants. Nothing to see there. Move along. Jupiter and Saturn are mostly helium and hydrogen. Nothing to see there. Move along, move along, move along. But that's not the worldview that's not the type of worldview that actually has explanatory power. It's the type of worldview that just wants to just ignore what's actually there. And I think the reason why they ignore it is because they can't explain it. So instead of trying to explain something, they go, well, yeah, this is just this, forget about it, don't worry about it. And it's kind of funny because they look outside of the solar system at this test object, this planet, this exoplanet, which is an evolved star, which is orbiting about 100 light years from here, and they're going, I wonder if there's water on the surface. You don't need to do that. The water that exists in the galaxy is inside of gas giants as they evolve, inside of stars as they evolve. So which means the habitable zone, as a star evolves, it internalizes, and water exists right underneath the surface of objects like Neptune. But the interior of Neptune is too hot, for instance. So you have the exterior of Neptune, which is really blue, has methane in it, has hydrogen, helium. But you go deeper into the interior, I guarantee you're going to find a hell of a lot of water in the form of rain. There's going to be a shitload of rain. And the idea that the rain doesn't actually exist, that the water doesn't exist because there isn't a solid surface yet, it's supposedly a gas giant, is kind of myopic. It's very short-sighted of these astronomers to just say, well, the habitable zone is something that exists outside of a star. No, it's something that internalizes as a star evolves. And the other graph here, I didn't put this in the paper, but basically you have your very young star, and you have objects orbiting it way out here. And then as the star cools, shrinks, and collapses, that zone moves closer and closer and closer and closer and closer and closer, and eventually internalizes. And we can see, we'll probably be able to see when, our observation techniques and our probes get more advanced. We'll see that objects like Neptune and Uranus and Jupiter and Saturn, they have areas inside their deep atmosphere that contain a hell of a lot of water. So this is where the actual habitable zone is located, meaning these objects, they're very, very hot in their interiors. They're not ice giants. And that sort of understanding of that, you know, when we're looking at Jupiter, Saturn, Neptune, Uranus, and we're looking at these so-called exoplanets, which are a very highly evolved star, if you sort of look at them as being a single stage in a very long process, like this graph outlines here, you sort of can try to pull away from the mentality that all these objects are dependent upon the sun, when the sun itself is its own young planet in its own stage of evolution, and it's not related to the objects orbiting it at all. So basically, in a nutshell, we have two habitable zones. We have an external one that the NASA people focus on, and they say this is the most important green zone. And then you have stellar metamorphosis, where the green zone internalizes to the star, and it can also orbit around a hotter host at the same time. So it can have a double habitable zone, two habitable zones. And that's what I think Earth is like right now. And that's the most important aspect of it. It isn't just, well, we have to find an object in orbit around a hotter host at a certain area, at a certain distance from its host. No, we have to actually find out what that object is composed of, if it even has water oceans. I mean, sure, it could be an object inside the habitable zone, but that doesn't necessarily mean that it has water oceans. It could be a giant dead rock for all we know. So I just wanted to call them out on that. Of course, when you guys read the article, it's kind of funny that NASA people, they still call planets as something being independent of stars, like as if it's this different object altogether. They don't realize that a star is a young planet and a planet is an ancient star. They're the same things. So I don't know. I guess the mentality has to change over time, and it's just going to take a lot more time than I realized. All right, you guys. I think I've blabbed long enough. I'll link this paper to the bottom of the page and the article. Later.